Just introduce
From
yourself.
From the Robo Rio up through the Raspberry Pi and all the microprocessing that we're doing, co-processing.
Computing or mechanical stuff?
Whatever you got.
Computing, but
Tell me who you are and which school you represent.
Oh, sure. I'm Weaver, and I'm from Hershey, so Hershey High School.
Hershey High School. Great.
Yep.
So give us a breakdown. This is your award-winning 2022 robot.
Yeah.
Cool.
Yeah. So the robot has lots and lots of different components, but talking with the computing on the robot here, right down here, it's a little hidden, but this gray rectangle right here is called the Robo Rio. This is basically the core of the robot. This is what runs all of the code and everything. It's basically the computer that runs on the robot.
It's got a mini-Mac sitting in there.
Not quite as powerful, but yeah, pretty similar.
Oh, pretty specific. So
yeah, it's just designed for this. Then over here, this is another computing device that we use. This is called a limelight, and what it does is it shines green light out at the retroreflective tape on the targets, and that allows us to basically identify where we are relative to.
So then that controls your shot.
Yes, we use that to adjust.
I was wondering what you were doing to do that. I found it so interesting to watch the range that all these robots had for shooting, because they didn't go to one spot. Now some it seemed like they had to pull into the goal to only shoot up and over. Yeah. They didn't have a range to them.
It depends on how they designed their robot. Some teams prioritize that. And then moving over here, we also have a camera in the back that allows us to see balls behind us. But not only that, it's also fed into a small computer out in the front called a Raspberry Pi. And that runs a neural network. So that runs some artificial intelligence that actually can figure out where on the field all the balls are. And then we can actually automatically move over and pick them up.
That's your targeting solution. Yeah, that was pretty cool to read about.
And that's what won us some of our awards at the competitions.
So since you're in the programming area, were you part of the team that wrote that code?
Yeah, I'm the lead programmer. So I was in charge of writing.
There we go. Let's go right to the top. I love it. Well, congratulations. How cool is that? I enjoyed reading about the Innovation Award you guys kept taking at all your tournaments. That was very cool. I've been following you for a while. I'm kind of your stalker out there.
No, you're good.
So for those that are watching right now, this is actually something I'm recording. But the idea was the robots were going around scooping up balls.
Yep.
And so this is actually what you would do to collect them.
Yeah, so this intake arm pops down. These wheels all spin with some Velcro on them. That pulls the ball up in through here. Then it goes through these brushes that add some extra force on here to make sure it doesn't roll back out.
Okay.
Then we have a lower belt here. As this belt runs, obviously it runs a little faster than that. It moves up through the system. Now, notice this little red light here.
Right.
We have these different sensors in here that detect when there's a ball present in the robot. So we also have another one right over here on the side. So then as this wheel turns, this belt turns, as this ball moves up, this sensor is now detecting that there's a ball there on the side. So now we know to stop this system from moving and wait for a second ball to come in and activate this sensor right here.
Okay, so you always needed a second ball to take a shot?
No, but it helps us make sure that the balls are correctly spaced within the robot. Because if we just keep running these wheels, then this ball is going to pop out the front, this one, or they're going to jam up together. So we keep it so that we have these sensors so that we just always stop the balls at the same spot, so that we can make sure that we're shooting in the same way every time. And that we don't jam up the inside of the robot. And then moving on to the shooter over here, we have these two separate wheels that are each controlled, these flywheels that are each controlled by their own motors right here. And these both spin up at separate speeds, and that allows us to create a spin.
Arc.
Yeah, and so we can create whatever arc we want because of the two separate wheels here. So we can do back spin shots, we can do front spin, or top spin shots. We like top spin.
So you have a 3-point shot with this thing?
Oh yes, we've made shots from all the way back over there, but it just depends on what works best at each competition.
I saw there was a lot of spin on the balls because when they'd hit the funnel, some of the teams didn't have that as controlled and never going out, and others were just going straight on, just complete switch.
Oh yeah, I mean that's one of the things that that's pretty important here is the height of the shooter. Mm-hmm. Our shooter is tall enough that we're able to achieve a decent arc. Some robots that had taller shots actually were able to get an even nicer arc in there that just went right down in. We were able to get enough, but a taller robot might be a little more top heavy, but it can get that shot a little bit cleaner, whereas some shorter robots have more of a struggle getting it in consistently.
Very cool.
Yeah.
Well, thanks for the tour. We'll do some more pieces here.